Okay, so we pick up here, and on the last problem we applied that, but if an angle is greater than 360, or 2 pi, or less than 360, or negative 2 pi, we find, basically we find a coterminal angle first, and then we would find our reference angle. And that's what we did in that last problem that we almost forgot about. Okay, so let's see some practice. First of all, is this on the unit circle? No, then that's a good rule of thumb to know that you should do find the coterminal angle first. So coterminal just means it starts and terminates in the same location. So 580 degrees, what would I do to find coterminal? Subtract out one revolution, which in degrees is 360, so coterminal would be 220 degrees. Okay, so coterminal is 220 degrees. Now let's find the reference angle to that. So roughly 220. 220 is going to be over here in the third quadrant. I want to know coterminal to that one, the reference angle. The reference angle takes me back to the x-axis. So if this is 220, that angle is 220, how do I find this red angle, which is called the reference angle is theta prime? Well, we take that 220 and we subtract out 180, which is going to be theta. Our reference angle is going to be 40 degrees. So that means this red angle is 40 degrees. Alright, let's work on this next one. So we have, that's hard to see, it's 8 pi over 3. So first of all, look at your unit circle. Is 8 pi over 3 on it? No, that means we should be looking for coterminal. Now, this time it's in radians, so how can I take out one revolution all the way around the unit circle? Subtract out 2 pi. So let's find coterminal first, which getting a common denominator would be so 8 pi over 3 is in the exact same location as 2 pi over 3. It terminates in the same position. So we're going to now do a reference angle to 2 pi over 3. So we look on our unit circle and we see that 2 pi over 3 is an angle in the second quadrant. We are looking for the reference angle in red. Okay, so that would be, what's the radian equivalent of this value? Pi. So instead of 180, it's pi for radian. So pi, subtract out 2 pi over 3. We want a common denominator. So our reference angle in this particular case is pi thirds. And so why do we need reference angles? This next section we're going to practice because it says use reference angles to evaluate the trig function. So now we're going to kind of bring it all together. And the idea is that you're first going to find the reference angle, and then you're going to use the quadrant, which theta originally lies in, to determine the sine. So we got to remember to do this one. This is the easy part to forget, is this afterwards we're going to make sure to apply the sine. Alright, sine of 135. Well, 135 is on my unit circle, so I don't need to go find coterminal. I can just start with the reference angle. So look on your unit circle and you can see that 135 is in quadrant 2. So the reference angle is this angle right here. So I'm going to say 180 minus 135 to get the reference angle. So reference angle is going to be 45 degrees. So I want to calculate the sine of 45 degrees. Okay, so I'm using this trig function, sine of 45 degrees. Look at your unit circle. Here's your unit circle. What's the sine of 45 degrees? It's the y value. Square root of 2 over 2. So now we're using our unit circle as a tool. And we just used reference angle to calculate that. Okay, so cotangent of negative pi over 3. First of all, is this on the unit circle? No, so this means we need to find coterminal. So pause it, find coterminal. Okay, so we added one revolution, which is 2 pi, common denominator. Coterminal is 5 pi over 3. We look on the unit circle. Yes, it's here. It's in this location. So I'm looking for a reference angle, which is here. So in this case, we would take, to find the reference angle, we would take this value, which is 2 pi, and subtract 5 pi over 3. So did a common denominator and solve. Okay, once we have a common denominator, we can see that pi over 3 is equal to theta prom. So this is our reference angle. Now we want to calculate cotangent of pi over 3. Okay, now we're going to go back. We found our reference angle. So cotangent of pi over 3. Okay, cotangent is your x over your y, and this is a pi over 3, so we're using this value right here, so it's going to be 1/2 over square root of 3 over 2. Okay, and now we want to simplify this by multiplying by the reciprocal. After you multiply by the reciprocal, we still have 1 over square root of 3, and then we rationalize the denominator to get square root of 3 over 3. Now, this is the part that's easy to forget. We go back to the original and find out the sine. What is going to be the cotangent in this position? Positive or negative? Well, all students take calculus. Cotangent's only positive here, so that means it's negative everywhere else. So go back and apply the sine for that quadrant. Okay, sine of 300. So is 300 on the unit circle? Yes, so that means we don't need to do the coterminal stuff. We only need to do that when it's not. Let's go ahead, and 300 we can see is over here in quadrant. Well, 300's in this quadrant, so the reference angle, angle theta, would be here. So that will be 360 minus 300. So the reference angle is 60 degrees. So now we just want to evaluate the sine of 60 degrees. Okay, we come over here to 60 degrees. And what is the sine value? Square root of 3 over 2. Good. Now, don't forget, the last step is to apply the sine. So what is the sine value in this particular quadrant? Negative. Good. Don't forget to apply the sine value as your last step. Okay, the next one is tangent of 14 pi over 3. So first of all, look for 14 pi over 3. Not over here. So how would I take out a revolution in radians? Subtract out 2 pi. Okay, that, find a common denominator, it's 8 pi over 3. I look over here. 8 pi over 3 is still not on my unit circle, so what do? Subtract out another 2 pi. Okay, 2 pi over 3. Is it over here? Yes, it's right here in quadrant 2, so good. So now I found coterminal, and I want to draw a sketch. Okay, so this is where 2 pi over 3 is, and then this is going to be, the red is going to be angle theta, which is my reference angle, and I find that by saying pi minus 2 pi over 3. Calculate that, finding a common denominator, and my reference angle is pi thirds. So now I want to calculate the tangent, coming back to here, tangent of pi over 3. So using my reference angle. Okay, what is the definition for tangent? This is your, recall, this is your y over x. So come to pi thirds. Now here's how we use our unit circle. Come to pi thirds, which is here. Okay, and what is the y value over the x value? So that's going to be square root of 3 over 2 is the y value. The x value is 1/2. Now we want to do some algebra here, which you can see they're both over 2, so it'd simplify, but if you're not good at seeing that, let me just show every step. Reduce it, the whole bottom's going to simplify, and you get square root of 3 over 1, which is square root of 3. Now, don't forget to apply the sine. We're here in this quadrant. What is the sine of tangent in this quadrant? Negative. If you're not quite sure where I'm getting that from, remember all students take calculus. It's saying tangent's only positive here and here because all of them are positive here and here. So if it's in this one, we know the tangent's negative. That's what we mean by apply the sine. Okay. I'm out of time, but I'm going to go ahead and show all the values for secant of negative 17 pi. I'm going to go ahead and just pause the video and then put all the work for it, and you can kind of work your way through that one. Okay, so this is going to be negative 17 divided by 4. It's negative 4.5. So you can see that you're going to need to go around 2 pi, and it's still not on the unit circle. Add 2 pi, it's still not on the unit circle. Add 2 pi, so finally you get 7 pi over 4. Find your reference angle, evaluate secant of theta, and then that should be what you get.